Greetings and welcome. I'm very excited to share with you some amazing new discoveries. It's been said that chance favors the prepared mind. Over the last couple of years, this has proven itself to be true in my life on numerous occasions. My chiropractic studies helped me to recognize the patterns that I've shared in my previous videos. 5 years of courses in subjects like anatomy, physiology, histology, biology, they've all prepared me to begin to recognize patterns in the stones. The revelations that I've had didn't come until I was willing to let go of preconceived notions and allow myself to contemplate the absurd. This is the sort of thinking that leads to new discoveries. The greatest innovations are rarely, if ever, made by those following the herd. The findings I've shared in my videos have come because of a willingness to ask unusual questions and to look with new eyes at the world around me. In those moments, when I've recognized the most astonishing patterns, the hairs on my arms have stood on end. Our bodies have a built-in wisdom. They're far more than just machines. They speak to us in a variety of ways, and if we ignore the messages, it's like shrugging off guardian angels as they whisper in our ears. Since I discovered the heart stones, I've gathered literally hundreds. I find them everywhere I go, and their pattern is so easily recognizable to me now that it has become effortless to spot them. They literally jump out at me, distinguishing themselves from everything around as they're so unique. Of the many I've found, one of them is particularly special to me because it's tied to both synchronicity and love. I found it a couple months back. I'd been working frantically all day on a new video, and after some trouble with rendering and upload, I had only 15 minutes to stretch my legs before premiering the video and hopping into the chat. On that brief walk, I had a wonderful call with the woman I love, and just after we said goodbye, I saw a notification for what turned out to be a beautiful comment on one of my videos. In the very next moment, I noticed that my channel had passed the 1,000 subscriber mark. I looked down and noticed a tiny stone on the sidewalk in front of me. It was the only rock anywhere near me, and I was immediately drawn to its recognizable shape. I bent down to pick it up, and then turning it over, I couldn't help but laugh. There was the intraventricular sulcus, the classic harp shape, and even a little indentation at the top where the aorta might have been. Synchronicities have abounded in my study of the mountain Montgo and in the heart rocks, and in the information I will share with you today as well. Synchronicities are the little messages from the universe that tell us that we're on the right track. They occur more and more as we open ourselves up to honest inquiry, ask for guidance, and go looking for honest answers. Recently, in the comment thread of one of the videos I made about petrified organs, someone said, "The heart is a rope." I didn't understand the comment, and it wasn't until later when someone posted a link to a video called the Helical Heart that I made the discoveries that I'll share with you today. For centuries, scientists puzzled over the mysteries surrounding the supposed pumping function of the heart. To this day, the vast majority of people still believe the heart to be a pump that contracts to push the blood out to the body and then passively fills on relaxation. It's said that if one were to lay all of the blood vessels of a small child end to end, that the length would stretch over 60,000 miles. Yet despite the high viscosity of blood, our little hearts, no bigger than the size of our fists, are able to deliver blood to every cell of the body throughout our entire lives. This presented a paradox for scientists for centuries. How could the heart, if it were indeed a pump, in a constant cycle of contraction and relaxation, be responsible for such a widespread delivery? Even if we were to ignore the problems with the idea that the blood could passively return to the heart on relaxation, the problem still remains about how such a small pump could supply every cell of the body through thousands of miles of blood vessels. This centuries-old mystery was solved in the 70s in the most remarkable way by the Spanish doctor Francisco Torrent-Guasp, also known as Paco.
In 1864, Pettigrew, a well-known British professor of anatomy, described the spatial organization of the heart fibers as, quote, an arrangement so unusual and perplexing that it has long been considered as forming a kind of Gordian knot in anatomy. Of the complexity of the arrangement, I need not speak further than to say that Vesalius, Albinus, Haller, and de Blainville all confessed their inability to unravel it, unquote. In the early 1950s, as a fourth-year medical student at Salamanca University in Spain, Francisco Torrent-Guasp began an anatomical study of the heart to prove scientifically that his theory and the early observations of Erasistratus, Galen, and others were indeed correct.
Early in my career, I realized that something was wrong in the classical conception of the function of the heart. I realized that besides the systolic action, ejection of blood, there should exist a diastolic action of the heart to suck blood.
I learned about the ventricular band when I visited Barcelona about a year and a half ago, and I went over to talk to some colleagues about a new operation we're doing for heart failure, and they suggested that there was something in Barcelona that had dissected the heart out and had some ideas about cardiac anatomy, and I had never heard of Dr. Francisco Torrent-Guasp. And he and I met, and the first thing he told me is that my concept of how the heart was formed was not accurate. Then he told me that the heart's the way it has its conduction that I understood is probably not accurate. And in fact, the heart's a rope. And I think that I heard something like that, and I said, that's really amazing. I can't believe it. But he then showed us exactly how the heart was formed and had reduced it in its simplest possible category. And I said, that's truly amazing, because he had dissected segments of the heart, and he showed us that his concept of a rope was very appropriate.
After 25 years of dissections, Francisco Torrent-Guasp finally unraveled the Gordian knot.
And I was, during 25 years, making dissections. And I remember that all these anatomical facts I saw, they were like a puzzle. Yeah, from my dissections, I arrived to the conclusion that the ventricular myocardium was represented by a muscular band that was running from the root of the pulmonary artery to the root of the aorta. And that is really my contribution to the knowledge of the macroscopic structure of the heart.
What you are about to see is the dissection of the myocardial ventricular band performed by Francisco Torrent-Guasp. Here, a cow heart will be dissected. All mammals and birds were found to have a similar heart structure. The heart is first boiled in water to soften the connective tissue. The atria, aorta, pulmonary and coronary arteries, as well as some fat, are then removed. Using only his fingers to bluntly dissect the heart, just following the natural directions of the fiber, Torrent-Guasp begins by cutting through the aberrant fibers along the sulcus and separating the pulmonary artery from the aorta. In this manner, the free wall of the right ventricle can be opened, revealing the right ventricular cavity. Here begins a cleavage plane that must be followed all the way to the root of the aorta. At this point, you can see, once again following the direction of the fibers, how they descend into the well of the left ventricle. Next, Torrent-Guasp cuts the left fibrous trigone and follows the descending fibers, separating them from the more superficial ones. Torrent-Guasp continues the dissection, following the cleavage plane, separating the two layers. Then, by cutting the right trigone, he is able to free the aorta and unravel the myocardial band. The ventricular myocardial band, running from the root of the pulmonary artery to the root of the aorta. A singular muscular band that twists and loops like a rope into a helical structure, forming the left and right cavities of the ventricles.
Take a close look at this image and notice where the three different sections of the heart meet. We'll be revisiting this in a moment, and I'll be showing you how this relates to the heart rocks, but first I want to cover a couple of other topics. Someone whose work ties inextricably into the discoveries of Petro-Guasp is the Austrian-born Viktor Shauberger. Schauberger was a philosopher, inventor, and what many consider to be the Nikola Tesla of water. Through close observation of nature, he made discoveries that could, if implemented today on a widespread scale, solve many of the world's energy and pollution problems. He made numerous discoveries regarding spirals and vortexes in water and how these could be harnessed as natural, non-toxic energy sources and also be used for purification as well.
Now witness a vortex.
So every single thing in this universe is moving. The interesting thing is that all of that movement in nature has a particular spiraling path. Nature never ever moves in a straight line, no such thing. So that is nature's streamlining principle. When I froze the whirlpool that you see in your bathtub, you pull the plug out, there's the whirlpool. If you freeze that whirlpool, it's exactly the same geometry as a hurricane or a tornado or any other spiral, the cochlea of your ear. This shape is archetypal in nature. And so when I froze this, I was then able to rotate it and create. Because I had a frozen whirlpool, I was able to create a whirlpool. So one of the first things that I used it on, particularly in America, there are great big holding tanks. Well, that water gets stagnant. The municipalities that manage that water have to put chlorine and chloramines into the water. The problem is better solved by mixing that water. Generally throughout the world, if you want to mix water, it's very expensive. I put one of these frozen whirlpools in the bottom of one of these tanks, 6 inches high, 4 inches wide, and I rotated it with a couple of 100 watts of power, a couple of light bulbs of power, and I found it was able to mix an entire tank of water, 10 million gallons, which from an engineering point of view is not even conceivably possible. So from there, I started adapting these shapes into fans. Fans use 18% of the world's electrical energy. They're not terribly efficient. We found time and time again we could take the best fan in the world and reduce its energy by as much as 30%. So pretty much everything in an industrial world can be improved by taking these shapes from nature and reconfiguring what engineers build today.
In a moment, I'll show you how this information relates to the discoveries I've made about the heart rocks. But first I want to share with you another of the amazing discoveries of Petro-Guasp and how it dovetails perfectly with the works of Schauberger. Once Guasp had discovered the fundamental structure of the heart's Gordian knot, he set about trying to solve the riddle of how that structure could be capable of delivering blood to the unimaginable number of blood vessels in the body, or more importantly, how that blood could possibly be returned to the heart.
When I looked at the heart the first time, I saw a circumferential basal loop, and then I saw a descending limb and an ascending limb. And they curled around each other, had a helix, and had a vortex at the tip of the ventricle. And the angles at which they go is about 60 degrees, 60 degrees going down and 60 degrees going up, and they cross each other in that way. And for years, people had wondered why that happened in the septum, why the heart looked that way. And I realized this was really a spiral, and I began to think about spirals, and I began to understand that the spirals are almost the master plan of nature in terms of structure and in terms of rhythm. And if you begin to look at spirals, if you look at a spiral simply and pick the middle of the spiral up, you'd form a helix. And of course, the heart is a helix.
Using a unique imaging technique to examine the architecture of the heart, a cow heart is first inflated with compressed air. Then, in a series of X-ray images looking down on the heart, the helical structure of the muscular band is clearly revealed as we move down into the apex of the left ventricle. Once again, notice how the loops of the band turn in opposition. Two reciprocal spirals merging at the apex. The spiraling helical structure of the ventricular band is a pattern found throughout nature. You can see it in the patterns of seashells, in the growing flower buds of a daisy. A ram's horn gets its strength from the spirals within spirals of its architecture. The spiral is a common formation at every scale of nature, from the DNA molecule to global weather systems, all the way up to the stars.
You see this correlation between a spiral formation in nature, which is common in plants, shells, fish, heaven, all different areas, and the heart seems to be one part of that spiral. And so the design of the ventricle seems to be a natural design. That is, it's no different than many of the other spirals in nature, it's just that we just discovered it.
With the discovery of the ventricular band, Torrent-Guasp had only solved one piece of the puzzle. How the band worked came next.
When I arrived to evidence the macroscopic structure of the ventricular myocardium, start the problem at once that to try to understand how the heart, by means of this structure, of this helical structure of the ventricular myocardium, how the heart could be able to develop, to perform its two actions. I mean, the systolic action, ejection of blood, and the diastolic action, suction of blood. During 23 years, I was thinking about this problem. I made a lot of hypotheses, but no one was convincing me. Until it arrived one moment in which I was invited to give a talk in a hospital in Madrid. And I remember that after giving the talk, somebody put a videotape in a TV monitor, and I saw the heart, normal human heart, working. And when I saw this imaging, then the light came to my brain, and then I realized what was the mechanical trick used by the heart.
What Torrent-Guasp observed was the base of the heart moving down and the walls thickening during ejection, and then the base moving up forcefully, increasing the volume of the heart during diastole. All the while, the apex stays in place, virtually motionless.
The apical loop, the fibers are vertical, like my fingers, and the basal loop, the fibers are horizontal, like my other fingers. And I realized that the movement of the heart, made by the heart are the following ones. The base is going up and is coming down on the apical loop, which remains motionless.
Like a piston and cylinder, it is the forceful decrease in volume that pushes the blood out, and it's the forceful increase in volume that creates a potential vacuum, which sucks in the blood. Only in the heart, it is the cylinder or basal loop that moves up and down, while the piston twists to move the cylinder. The mechanical trick referred to by Torrent-Guasp occurs in the contraction of the apical loop. When the wave of contraction reaches the descendant segment, the muscle shortens and pulls the basal loop, the cylinder, down towards the apex. When the contraction continues on the relaxed ascendant segment, the fibers stiffen and reciprocally twist to push the basal loop back up. Torrent-Guasp equates this muscle response to the contractions of a cobra, whose muscle fibers also stiffen and rise when it lifts its head far above the ground. After nearly 50 years, Torrent-Guasp's revolutionary and evolutionary concept of the heart was almost complete, when a new nuclear imaging technique was employed to look at the contractions of the heart. Called a MUGA-scan, isotopes along the heart are excited and change colors when the heart muscle contracts. With an understanding of the loops of the ventricular band, it is possible to follow the changing isotopes and visualize the wave of contraction that contradicts conventional knowledge. The recognized sequence is from apex to base, yet this method shows progression in an opposite direction, from base to apex. Many call it the cardiac dance, the twisting, pulsing rhythms of the human heart in motion. Now, for the first time in history, it can be understood as the sequential movement of the muscular band, starting just below the pulmonary artery and ending where the band touches the aorta.
Francisco Torrent-Guasp's discoveries are quite simply monumental, and in my opinion should definitely have earned him a Nobel Prize. Seeing the Helical Heart led me to an aha moment where I realized that there were a couple of features in the heart stones that I had missed, just because I didn't really understand the true nature of the heart. In the Petrified Organs video that I did, I go through the heart rocks and I show the different themes that can emerge. In general, they'll take on this harp shape. They'll have openings oftentimes, or the indentations and the remains of openings on the side and on the top, the side being the pulmonary arteries and the top being the aorta. They also take on this shape where they curve on the underside very often, or they're just flat. And then the front will typically have like a faceted quality. There's curves that go in on the sides, shown very, very prominently here. This is because as the heart dies and it goes into contraction, so the ventricles will curve inward oftentimes. And you can see this one has that curve on the bottom as well. So seeing the video about Paco Torrent-Guasp helped me to realize that I had missed a couple of features, and that has to do with the way in which the heart folds up and you get these overlaps of the different lobes. So originally when I saw these rocks, all of these rocks I picked out already before seeing that video, just because they had these typical characteristics. They've got the blood vessel opening on the top, they have the harp shape, and and so seeing the video about Paco Torrent-Guasp helped me to recognize that these lines, which I originally thought were just perhaps the remains of the fatty portions of the heart, are actually more likely where they are overlapping the different lobes. It's important to remember that every species has a slightly different heart, different heart sizes, and no two are going to be alike. So in order to spot these, you have to kind of know the overall themes. So I'm just going to show you some of these, and then we'll compare them to the example of the dissected heart. So if we look here, you can see that it really comes alive. See the lines here of the lobes, and there as well. Here you can make out the aortal opening on top, and then just very faintly you can see a line there, but underwater it starts to come out a bit more. And here it's really noticeable. That bottom curve, openings on the top, and a little hint of a lobe there. This one definitely looks like it was overlapped. Again, that curve right there. Indentation at the top. Some obviously exhibit more features than others. There's your opening on the top. Again. Indentation on the top. Clearly defined lobe, harp shape, and a lobe on the backside. It may not be that each and every one of these is a heart, but based on what I'm finding, I'm more and more confident about the ones that are hearts and the ones that aren't. Here's another one with a harp shape and the lobe. Not so noticeable until it gets wet. And then you can see there's a curved line that comes right down. Indentation on the top. Does that look like something that would just naturally happen by rolling around with erosion? None of these are broken. I've shown that in the other videos. As soon as there's any kind of a fracture, it's immediately noticeable. See there? Your indentation, pulmonary artery, aorta, harp shape, and then the curves of the overlaps. There's your curved underside, harp shape, very pronounced lines for the lobes, aortal opening there. Another curve, indentation on the top, pulmonary arteries. And then this one, the back side, the line coming down. Indentation for the aorta and the investitures where it attached in, harp shape, curving in where the ventricles were. I've shown this one as well. You can see the lobes are very pronounced. The overlap. See, there's an opening for the aorta here, but then there's a line that continues down. And you can see that in the dissection that Torrent-Guasp does. There's the curve again. And the aortal opening at the top. It's amazing how often that's there, isn't it? Right in the right place. Blood vessel openings, the line for the overlapping lobes. Harp shape. Okay, so that's what I wanted to show you with these. One last one here. Openings. And then another one of those curves. Even with his amazing discoveries about the form and function of the helical heart, I imagine that Guasp still had many unanswered questions, as do I. For example, I'm still not convinced that this piston-like toroidal implosion is in and of itself enough to completely explain the motion of blood throughout the body, especially considering the high viscosity of blood and the unimaginable length of our internal piping. As a kid, I was always taken by the drawings of M.C. Escher. He drew amazing two-dimensional images of 3D structures that could not possibly exist. Through him, I discovered the idea of the Möbius strip, a one-sided three-dimensional object. Try to wrap your head around that idea, a one-sided three-dimensional object. The interesting thing about the Möbius strip is that it can exist in our three-dimensional world.
A simple loop has two sides. You can't get from the red side to the green side without crossing the edge. If you cut the loop, twist one end by 180 degrees, or pi radians, and connect them again, you will have a Möbius strip, a mathematically non-orientable surface with only one boundary. Now you can travel along the red side to the green without going over the edge. If you twist the end again for a total of 360 degrees, or 2 pi radians, you will have a twisted loop. You again can't get from the red side to the green side.
How does this relate to the topic at hand? Well, after picking my jaw up from the floor while watching Guasp do his dissection of the heart, I found my jaw right back down there again as I watched him roll the heart back up. The very first move he makes, following the natural fibers of the band, is a half twist before rolling it back up and returning the heart to its original shape. So, in addition to being a bidirectional toroidal vortex, the heart also appears to be a Möbius strip. While doing an image search the other day, it occurred to me that the shape of the red blood cells themselves are toroidal. I wonder if the blood isn't somehow magnetically pulled through the blood vessels. I've searched the interwebs, and apart from metaphorical references to the heart being a Möbius strip, I found nothing specific regarding the action of the cardiovascular system. So if no one else has made such a correlation, remember that you heard it here first. Geology appears to be in great need of revision, As more and more new information comes to light, it seems inevitable that geology will slowly morph into a new discipline, eventually becoming biogeology. My hope is that someday there will be reliable and cheap tests that will allow us to easily determine what something once was. I can't wait. Imagine to be able to go down to a local store and buy yourself a Test a Titan kit, or perhaps another called Organ ID 123. I'm still looking into performing DNA tests on some of the stones I've gathered, and if anyone knows an economic, reliable method, I'd appreciate some info. In the meantime, I'll be attempting to network here in the region in hopes of finding someone with access to a CAT scan or MRI equipment who might be willing to facilitate research. 3D imaging could certainly reveal a great deal of the internal structures of the stones in a way that breaking them open does not. As a researcher, Guasp was the quintessential lone wolf, working the majority of his career with his groundbreaking discoveries going unrecognized by his peers. But finally one day he was able to give what he considered to be the lecture of his life, displaying a heart directly before cardiologists in Madrid, Spain. And at the end of the presentation, the auditorium stood up and, standing ovation and applause. And fully satisfied, he went home to his hotel room and he told his wife, and actually died of a heart attack that night. When I read this and I heard about his life story, I was brought to tears. And it wasn't until I got to the end of one of the articles that I found out that Paco Torrent-Guasp had lived and worked his entire life in Denia, Spain, which is literally 10 minutes from where I live, on the other side of the mountain Montgo. And already as I was hearing his story, I was upset because I was thinking how wonderful it would be to talk to him about what I've discovered about the rocks. Because if there was ever a cardiologist who was open-minded enough to consider the things that I'm presenting, it would be somebody like him. But he died in 2005, so 14 years ago. But I just find it utterly amazing, in another synchronicity, that this man, who is the most important person in history for helping us to broaden our understanding of the function and the nature of how the heart works, he was a solo investigator, all on his own, in a town just on the other side of Montgo. What are the odds?